Good morning, everyone. Today we are going to study one of the most important building blocks in programming, conditional instructions. Until now, all the algorithms we've written follow a straight path, a series of instructions that execute one after the other in the order we write them. That's called sequential logic, but real-life situations don't always follow one path. They depend on conditions. You decide what to wear based on the weather. You decide whether to study or rest based on your schedule. And just like we make decisions, our programs also need to make decisions. This chapter introduces how we write those decisions in algorithmic form. You will learn how to control the flow of execution in a program using 3 conditional structures: simple, complex, and multiple choice conditions. Let's begin with the first and most basic one, the simple condition. A simple condition checks whether something is true or false, and then performs an action if it is true. For example, if the student's average is greater than or equal to 10, they pass. We call that the if-then structure. It checks a condition. If the condition is true, a block of instructions is executed. If not, nothing happens, the program just moves on. Here's the format we use in algorithmic pseudocode. If condition then instructions. And if. And in C language, it looks like this: if, condition, instructions. Closing curly bracket. Let's try a concrete example. Suppose we ask the user to enter a number. If that number is negative, we display a warning message. Otherwise, we simply continue. So our algorithm might say, read x. If x less than 0 then, write, warning, negative number. And if, write, square is, x asterisk x. You see, only when the condition is true, when x less than 0, do we execute the line inside the block. Otherwise, the warning doesn't show. This is a simple, clear way to introduce selective execution into our algorithms. Now, what if we want to do one thing when the condition is true, and a different thing when it's false? That brings us to our second structure, the complex condition, or if, then, else. It looks like this: if condition then block A, else, block B, and if, and in C, if, condition, block A, else, block B, closing curly bracket. Let's take an example. Suppose we want to compute the absolute value of a number x. If x is greater than or equal to 0, we keep it. If it's less than 0, we take the opposite. In algorithmic logic, if x greater than equals 0 then y left pointing arrow x. Else, y left pointing arrow x. And if, in C, if x greater than equals 0, y equals x, else, y equals x. This structure is extremely useful when there are only 2 choices. And it helps keep your code clean and readable. In C, there's even a shorter version for cases like this, called the ternary operator. It looks like this: y equals, x greater than equals 0. X. This line means the same as the full if, else block, but in one line. You can also use it with strings. Status equals, average greater than equals 10. Admitted, adjourned. This is especially useful for assignments based on simple conditions. Now, what happens when we have more than 2 options? Suppose you want to ask the user to enter a number from 0 to 9 and display its English name, 0, 1, 2, and so on. Writing multiple if, else statements for each value would be long and messy. Instead, we use a multiple choice structure, called a switch or case structure. Here's how it works. In pseudocode, case value of 0, write, 0, 1, write, 1, else, write, not treated. End case. And in C, switch, NB, case 0, printf, 0, break, case 1, printf, 1, break, default, printf, not treated. Each case checks if the value of NB matches a specific number. When it finds a match, it executes the instructions under that case. The break statement tells the program to exit the switch block. Without it, the program would continue into the next case, which we usually don't want. The default case is optional but very useful for handling invalid inputs. This structure is ideal when you're checking one variable against many known values. Now let's talk briefly about how we build the conditions. We use 2 types of operators, comparison and logical. Comparison operators. Symbol meaning equals equal, equals not equal, less than, greater than, less than equals less or equal, greater than equals greater or equal. For example, if score greater than equals 10, this condition checks if the score is greater than or equal to 10. Logical operators. Sometimes we want to test multiple conditions at once. We use an and for in, for or, for not. Here's an example. If age greater than equals 18 and a nationality equals A. This condition only becomes true if both age is at least 18 and nationality is A. You'll use these operators a lot when working with form validation, decision-making, or complex rules in your applications. To help visualize these decisions, we can use flowcharts. In a flowchart, decisions are represented with a diamond shape. From that diamond, we draw two arrows, one for yes, true, and one for no, false. Each arrow leads to a different block of instructions. Flowcharts are incredibly useful when planning out your algorithms or debugging your logic. They let you see the program flow and catch logical errors before you even start coding. Finally, once you've understood these structures in pseudocode, the next step is to translate them into C language. This chapter shows you how to write conditions in C using if, else, and switch. Use scam to get input from the user. Use printf to display results. Combine logic with variables and expressions to solve real problems. By now, you should see how all the pieces come together: variables, input, output, and now, decisions. You're not just writing steps anymore, you're teaching the program how to choose based on logic. That's real programming. To conclude, I want you to remember this: conditional instructions are everywhere. They allow your program to make decisions, to adapt, to respond. Without them, your programs are blind. They follow the same path no matter what. But with conditions, your algorithms become dynamic, intelligent, and useful. Practice writing conditions. Try small examples like checking if a number is even or odd, finding the maximum between two numbers, giving a grade based on a score, displaying a menu and responding to user choices. These little exercises will build your confidence and your skills. This chapter is your gateway to interactive programming, and from here, we'll move on to loops, arrays, and even more powerful structures. Thank you.